B, although I'm pretty sure we did. I'm very certain we did part A. I believe it was one of, if not the first FRQ that we did this year. So hopefully it looked a little bit familiar. Hopefully part A was not too difficult for you. So let's go ahead and take a look at part A. All right, so we're given this little blurb here about what is a self-divisor. So I made a little bit of a checklist. First up, we're told that a self-divisor is a positive integer where every decimal digit, so every digit in the number, is a divisor of that number. That is, the number is evenly divisible by each and every one of its digits. For example, the number of 128 is a self-divisor because it is evenly divisible by 1, 2, and 8. However, 26 is not a self-divisor because it is not evenly divisible by the digit 6. So hopefully at this point the wheels are turning and you're starting to think about how you can first up isolate each individual digit, and then next, how can you update the number each time through the loop so that you are then able to isolate the next rightmost digit, okay, that digit on the end of the current number, so to speak, all right? So we're going to need a temp variable of sorts that will copy a reference to the original number that is the parameter given to us. That way we can also reference the number parameter within the body of our code as well, because we're going to need that if we are to test whether or not the digit that we are focused on divides the number evenly, okay? All right, so some other things to consider. No digits in the number can be 0, so if at any point we isolate a digit that's a 0, we're automatically going to return false. Since all of the digits must divide the number evenly, we are going to assume that the number is not a self-divisor, okay? So we're going to return false. If you were someone that set up a variable like self-divisor, Boolean self-divisor is assigned to, if you were going to assign it to anything, you would want to assign it to false, not true, okay? The reason being is because we have to check each and every digit in the number. All of the digits must evenly divide the number in order for it to be a self-divisor. What we don't want to happen in the context of the loop is have the code set the value of the of this variable that you may have declared initialized. You don't want it to assign it to true under one of these cases. For example, let's say you have a 2-digit number and the first number does not divide, or the first digit does not divide the number evenly, but the second one does. And your loop doesn't, let's say the way you have it set up, you are not automatically returning false as soon as you get a digit that does not divide the number evenly. So if you incorrectly continue to loop through and you reassign this variable to true based on the second digit dividing the number evenly, you may incorrectly return true when in fact you want to return false. Okay, so we're gonna assume it's false, and we're only going to return true after checking each and every single digit. Okay. Again, we're given a couple of examples. 128 is a self-divisor. 26 is not a self-divisor. 20 would not be a self-divisor. Okay. So let's go ahead and jump into code. I've got two different solutions that are quite similar. The first one is, I think, pretty much identical to what was given in the scoring guidelines. So as I said, this is sort of like a temp variable, current number, which is going to basically just store whatever the number is that was given to us, okay? Now, assuming that number is greater than 0, oh, and of course, we've declared and initialized a variable here called digit as well, okay? So if the current number is greater than 0, then we're going to continue to iterate through this loop, okay? And we can see down towards the bottom of the code, current number will be updated in line 27. So that will force a change in the state of that, of what's being held in that variable. So every time we're done looping, or we're done with the body of the loop, we'll come back up, check that condition. If that condition evaluates to true, then we'll re-enter the body of the loop. If it doesn't, if it's not true and we haven't already returned false, then we will return true. Okay. All right. So the digit we need to isolate. We know that in order to isolate a digit, the far rightmost digit in any number, we have to use modulus 10. Okay. Because when you divide any number by 10, the remainder will be whatever the digit was in the ones place. Okay, so 128 mod 10, it gives us the number 8. So 8 is stored in the digit variable. Now, first up, we need to check. We need to check to make sure that that digit is not 0. If it is 0, then we want to stop what we're doing and return false right then and there. Okay. Because if any digit is a 0, then it is not a self-divisor, and thus we return false. Next up, we have a second conditional that states if the number, now remember, the number never changes. The number is always whatever was given to us as the actual parameter. So if we're using 128, then when we evaluate line 22, number will always be 128. And that's the reason we needed this cur number variable, because the cur number is what's going to update each time through the loop, which will then allow us to isolate each individual digit. So 128 mod 8 does not equal 0, and thus we will not return false. But again, if the digit that we have currently isolated does not divide the number evenly, then we're going to return false, okay? So if neither of these are true, then we will update the current number variable by dividing it by 10. And what this does is it cuts off the far rightmost digit. So 128 divided by 10 is 12.8. And we know that since we're doing integer division, any information after the decimal place is lost, and thus the current number becomes 12. So we come back out, we evaluate line 14, 12 is greater than 0. Digit is now going to store 2. 12 mod 10 is 2. 2 is not equal to 0. 128 mod 2 does not equal 0, so we don't return false there. All right, so far so good. We are going to update the current number once more. 12 divided by 10 is 1 with a remainder of 2. So 1.2, but the 0.2 gets cut off. So current number is 1. 1 is greater than 0. We're back up to the while loop header. Let's isolate the digit. 1 mod 10 is 1. So the digit is 1. 1 is not equal to 0. 128 mod 1 is 0, so we don't return false here either. And then finally, 1 divided by 10 in integer division gives us 0. Come back up, 0 is not greater than 0. We exit the body of the loop, having avoided returning false at any point, and thus we will return true. So that is a sort of step-by-step analysis of an example in which case 128 is a self-divisor. Now, if you're someone that didn't have this set of code exactly the way you see it, that's perfectly fine. I've illustrated another example where I've consolidated the two conditional statements. All right, typically when you have two conditions, one after the other, that are testing things of a similar nature and returning the same thing, it's possible that you can combine them. So here in line 39, I have if the digit equals 0 or number mod digit does not equal 0, we're going to return false. So if either one of those conditions is true, you're going to stop what you're doing and return false. Okay? And again, the cur number will update assuming this condition here is false. Okay? Because if the condition being tested in line 39 evaluates to true, then the method returns false, and we will not get to this, and of course we will not get to this either. So all that's happening in this alternative example is we established a complex conditional in line 39. So this just reduced the number of lines of code in the method and accomplishes the same thing. I fit both conditions in a single if statement using the or symbol, but I noticed that you did that in your, yep, okay, great. Sounds good, Brittany. Any other questions before we move on to part B, which is the part of the question that we really want to focus on, because that's the part of the question that talks about arrays. So any questions or comments you'd like to make before we move on to part B? All right, then, ladies and gentlemen, let's move on to part B. So it's always important to read this stuff too before you actually read like the paragraph for part B. So remember, any code that's directly above a method header, those are just sort of like the comments for that particular method. So when it says like @param, it's giving you some information about the parameters that are associated with that method. And when it says @return, it's telling you something about what the method should return. Okay? So we have this method here, public static int array. All right, so the return type of this method is an array of integers. So this method is going to return an array of integers. First num self-divisors is the name of the method, and we have two parameters, int start and int num. So that's not all that telling. It doesn't give us a whole lot of information. Let's read about them though. It says @param start is the starting point for the values to be checked. Okay, precondition start is greater than 0. @param num is the size of the array to be returned. Okay, I find that interesting that it says size. We usually say length for an array, although I guess we could say size as well. You just have to know that you're using the array.length, not array.size. Okay, if you're going to reference the or how many elements there are in the array at some point. And the precondition is that num is also greater than 0. The return, so it says @return, so we are going to return an array containing the first num integers that are greater than or equal to start that are self-divisors. Okay, might be a little bit confusing. Let's get a little bit more context by taking a look at this paragraph here, which says you're going to write a first num self-divisors method, which takes two positive integers as parameters, representing a start value and a number of values. So the second integer parameter is going to represent the length of the array that will be returned. Okay, so if that second number is 3, we're going to have 3 elements in our array that are all self-divisors. So all of the elements in the array must be self-divisors, and more specifically, they're going to be the first self-divisors in order from the starting point that's given to us. Now, If the starting number is not a self-divisor, then we have to move on to the next number until we get to a number that is a self-divisor, at which point we will assign that number to a specific location in the array, and then increase the index and increase the value of that number, moving on to the next number, and we check to see if that one is a self-divisor. So, for example, first num self-divisors 10, 3 should return an array containing the values 11, 12, and 15, because the first three self-divisors that are greater than or equal to 10 are 11, 12, and 15. So 10, as we know, is not a self-divisor because it contains a 0. And thus, 10 is not found in the array that is returned. So what we're seeing here before we start developing any code is that, okay, I'm going to have some type of loop, and regardless of the condition that I'm testing, number, so the starting number, will be incremented no matter what, right? So if it's true, if the number that we evaluate is a self-divisor, great, we want to move on to, we'll fill it in, then move on to the next one. So you're going to have this variable start, which is going to increment no matter what. And then we're going to have an index variable that refers to the index or position of each element in the array that's to be returned. Now that index value will only increment if the number that we've currently evaluated is a self-divisor. Of course, when you declare and create an array of integers, the elements are set to a default value of 0. So we have an array that's just got 0, 0, 0 in it, assuming we're using the example 10, 3. Okay? Now we don't want to return 0, 0, 0 because, of course, zeros are not self-divisors, and that's not what the method is supposed to return. It's supposed to return numbers that are self-divisors from the starting point and onward until we've appropriately filled the array. Okay, so let's take a look at a possible solution. Go down a bit. All right, so if we are returning an array of integers, we need to declare and create an array of integers, okay? Now, when we first started writing methods together earlier in the year, I pretty much had you declare and create a variable that would match what you were told in this context right here, for every single example. Now, that's not always necessary. As we observed in part A, the return type here was Boolean, and it wasn't necessary for us to declare and create a Boolean variable that we returned. In some cases, you can just return the value itself, like true or false, okay? But you were certainly able to declare and create a Boolean variable for part A. B, I would say it's far more, I just can't see how you would do this problem without declaring and creating an array that is representative of the size or length given to us by the num parameter, okay? So it's absolutely essential, I believe, for this question to have the line of code that we do in line 60 there, all right? This creates the data structure and allows us to assign a value, assign an integer to a specific location in the array if that number we just evaluated is a self-divisor, okay? So that's what's happening in line 60. Line 62, we've declared and created an index variable that will be used in the while loop header. So we have index, which is assigned to 0. If index is less than num, the num that's given to us, okay, then you're going to continue to check for self-divisors. All right, so hopefully that's fairly straightforward as well. Num represents how many elements there will be in the array. So if there are 3 elements in the array, that means we need to assign values, we need to assign integers at positions 0, 1, and 2. So at some point, index will be 2, which is less than 3. We will increase the index to 3 at some point, and then when we evaluate line 63, when index finally gets to 3, 3 is not less than 3, so we'll exit the while loop and return ARR, which is the name of our array, okay, or that's the variable that refers to our array. All right, so back in the loop. When we first start, index is 0, and again, we're doing this with the actual parameters of 10, 3, okay, and we can use other examples as well. So if self-divisor given start, so if that's true, okay, I don't have to write equals equals true. When you have a conditional statement like this, all right, this is really a Boolean expression within the conditional header, so to speak. So if this evaluates to true, we'll enter the body of the condition. If it evaluates to false, then we won't enter the body of the condition. So it's not necessary, although you certainly wouldn't lose any points in line 65 if you put equals equals true, okay? All right, so let's continue. So if the number start is a self-divisor, then you are going to take start and assign it to the array at position index. So would be at position 0. And again, as I said, you're only going to increment the index if the number we've just evaluated is a self-divisor. Of course, you wouldn't want to increase the index no matter what, because if you did, then you could potentially have a 0 in your array. And that wouldn't make any sense because the array is supposed to return self-divisors only, okay? So we only increment the index if the number that's just been evaluated is a self-divisor. However, the starting value, okay, and you could have, in the solution, in the scoring guidelines, they had another temp variable where they reassigned start, or they assigned start to a variable called number, okay? If you did that, that's perfectly fine as well. I'm incrementing start no matter what, so whether it was or it wasn't a self-divisor. Of course, we most certainly want to move on to the next number if the number we've just evaluated is not a self-divisor, because our goal is to find the first 3 self-divisors that are greater than or equal to 10, given these parameters. And of course, we want to increase it even if it is a self-divisor, because if we didn't, if we only incremented start if the number was not a self-divisor, then what would happen is the array would contain that first number that is a self-divisor, and it would only fill in with that number. And that's not what we're being asked to do either, okay? So we come back up, we check to see if the index is still less than the num. If it is, we check to see if the next number is a self-divisor, in which case we assign it to array at position index, index plus plus if it is a self-divisor, and start plus plus no matter what. When we're finally done with the loop, we will return the array. Okay, and we can see this in action. Copied this over from APCS Awesome. System.out.print, self-divisors 4, first num self-divisors 10, 3, and it should print out 11, 12, and 15, which is, I'll rerun it. Give it a second here. All right, self-divisors for first num self-divisors 10, 3, 11, 12, 15, excellent. Self-divisors for first num self-divisors 22, 5, 22, 24, 33, 36, and 44. And if you're not sure, you can go through it. 22 is a self-divisor. Both 2 and 2 divide 22 evenly. 23 is not a self-divisor, okay, because 3 does not divide, well, actually, neither digit works. 24 is a self-divisor. 24 divided by 2 works. 24 divided by 4 works. 25 doesn't work. 26 doesn't work. 27 doesn't work. 28 doesn't work. 29, 30, 31, 32. Okay, and you can check all those. 33 is, 34 isn't, 35 isn't, 36 is, and then 37 through 43 are not self-divisors. 44 is. So those are the first 5 self-divisors that are greater than or equal to 22. Now, in lines 14 through 17 here, all I did was test the alternative solution to the is self-divide, the part A method, okay? And we can see that it works. I know that 128 is a self-divisor, so I simply concatenated this with just a little message. 128 should return true and is. And then because is divisor or is self-divisor is a static method, in order to make a call to it in another class, you must have the class name dot the method, okay? So self-divisor is the name of the class dot the method. Again, think static is a class method, so just use the class as instead of using an object. So self-divisor dot is divisor, 128 returns true, 26 returns false, 20 returns false, 12 returns true, and we can see that right down here. 128 true and is true, 26 false and returns false, 20 should return false and is false, and 12 should return, 12 should return true and is true. And there we go. Okay. All right. Any questions? Oh, I see some comments here. I have a problem with my main method, main class. Can't use maybe system.out.print try. All right, I'll check Tanmim. We can all take a look. Tanmim, my first guess is that maybe you didn't invoke the class the way I said. And that seems to be it. So notice here, Tanmim, this is a static method. This is a little bit different, again, than how we do these problems in JCreator, because we do it all in one class. But because the main method is in another class, we have to make a call to the class in order to use these methods here. So you have to say self, I can only read it, Tanmim. So before is self-divisor, you have to write self-divisor dot, okay? You have to call the class before you can invoke the method. Got it? Try that, Tanmim. So you have to write self-divisor dot and then is self-divisor. Okay? And try that and let me know if it works. It should work. All right. Oh boy. Hi there, Jeff. Sadly, we are just finishing up, although I'm pretty sure Tanmim is recording. So as soon as we finish up and he gets a chance, I'm sure he'll post the video as usual. Does anybody else have any questions about what we did in Part A and Part B? Any other questions? Well, one thing I'm going to urge you to do, I know that we've had some terrific weather over the last couple days, and I know from going out for a walk myself that, you know, of course I had my mask on and everything, but that there have been there were lots of people out, and you know, I think it's a good thing as long as you protect yourself. But I'm assuming a lot of people were out this weekend, you know, enjoying the weather, and that's perfectly fine. But just, you know, to reiterate, we have basically 10 days until the exam, the AP exam. So really just put your head down, work hard these next 10 days, and then I promise you, you'll be able to take a big exhale, okay? Especially with there are no Regents exams, right? So for our juniors, I know our seniors we're pretty much done after the APs anyway, but for our juniors who were going to be, you might have had to have taken maybe at least 3 Regents exams in June, you're not going to have to take those. So this is it. Like, we need to keep pushing here. Again, I'm not assigning a whole lot of work. I really, really just ask you that you go back and you study the problems, the FRQs that we have done. The ones that we've done, you should know those like backwards and forwards. Like, you can almost recite them. All right. And it's not because you're going to be asked to have memorized FRQs for the actual AP exam. It's because each question that we've done presents a slightly unique situation where you can develop a skill, right? There's a skill in each one of these questions that you can then apply to other questions. Okay. And I can promise you that after having done all the FRQs that we will have done by May 15th, if you have really gone back, it's not enough to just do them once. You got to read the problems again and then make connections and be like, okay, so under this kind of situation, I might want to use this type of code in this kind of situation, or I might want to use this kind of loop and things like that. So please go back and read over the problems and go over your solutions or the solutions that are provided in the scoring guidelines for the ones that we've done. And please try to stay on top. I know of the 27 people here right now, most of you are turning in the work, on time. Okay. So please keep staying on top of everything. Go back and look at those problems again. And Tanmim posted, another resource for us to look at on Google Classroom. I also posted the videos, the link to the YouTube videos that are review sessions done by the AP College Board. So please take a look at those as well. All right, they're like 40 to 45-minute videos. You could watch one a day. You can watch 2 a day, then not watch one the next day. But those are an excellent, excellent resource. Okay. I'm not sure off the top of my head what problem I'm going to assign next, but I'm going to assign a problem, and I'll let you know what that problem is in the next hour or so. And that problem will be due by end of day Wednesday. And then we'll assign another problem that will be due by midday on Friday. So we're going to go over 2 FRQs on Friday. Okay? 2 FRQs. So I'm giving you a little bit more work than I had the last couple weeks. We're going to do 3 FRQs this week instead of just 2. I don't think that's unreasonable. I'm sure somewhere in the country there are students doing, anywhere from 2 to 4 FRQs a day. Okay, I can promise you there's somewhere there's somebody doing, that many problems a day. And I'm not saying you have to, but I don't think 3 FRQs for the entire week is all that unreasonable. Okay? Good, Tanmim, good. Can you post a list of FRQs we should know forwards and backwards? Yes, Kayla, I will. I will have that up by the end of the day, okay? And I will also let you know within the hour what our next problem is going to be, okay? Probably more like in the next 15, 20 minutes, I'll post it, okay? So if there aren't any other questions, that's it for today. And I will see all of you again on Friday.